Welcome to Study Loop.
Okay, so this problem combines some momentum conservation with some energy conservation. The first thing we need to do is figure out how fast the block and bullet are moving after contact when they're stuck together. So our initial momentum, we'll call this pi, equals the mass of the bullet times the initial velocity of the bullet. There's no contribution from the block because it isn't moving. So this is 0.008 times 280, which equals 2.24 kilogram meter per second. We can set this equal to our final momentum. So I'll start here. P final equal to 2.24 equals the combined masses, m small b plus m big B, over the final velocity. I call this V final of the combined mass. So if I rearrange this and solve for V final, 2.24, the sum of the masses, 0.008 plus 0.992 is 1 kilogram. So our final velocity is just 2.24 meters per second. Okay, once I know the velocity of the block initially, that sets up my initial energy in the system because the spring is not compressed yet, so the only energy that is there is kinetic. So here we have 1/2 m, which is 1 kilogram, v squared. So rewrite this 1/2 v squared, which is 2.24 squared, equals 1/2 k times the total compression. The reason I use the total compression here is so that the only energy available when the spring is fully compressed and the block isn't moving is spring potential. So I can set these things directly equal to each other. Delta X max. So we have that if we rearrange this thing and solve for k equals 2.24 squared over 0.15. Sorry, that's squared here. Squared, which is 223 newtons per meter. Now, if we want to find t, or the period, we know that the period is going to be 2 pi times the square root of m over k. So this is the total m, which is 1. So this is 2 pi over 223, which equals 0.421 seconds.